Hi, and welcome to the Screencast Space 2.1. This is Screencast number 3. Last time we talked about how the revolution of Earth around the Sun, together with the tilt of the Earth's axis, caused the different seasons on Earth. And we talked about how that tilt caused the summer seasons when the tilt was towards the sun, and the winter seasons when the tilt was away from the sun. Part of that is also due to the angle that the sun hits Earth, and that's what we're going to talk about today. We are going to probably refer to our textbook today, so you might want to be open to page 48 and 49E. We will continue our notes in Cornell fashion. You do not have to start a new page. You can continue with where you left off. And the angles of sunlight is the new heading. So make sure that you make a new heading. All right, let's start. So the angle of sunlight affects the ground temperature. The higher the angle of the sun, the more concentrated the sunlight, the hotter the temperature, which is during the summertime. So in other words, when the sun is overhead more directly, then the sun's rays are much more concentrated, which heats up the ground a lot more. So that must mean in Arizona that it must be right overhead, because it's baking hot where we are in the summer, isn't it? Now, the lower the angle of the sun, the more spread out the sunlight is, the cooler the temperature, which is during our winter time. So again, when the tilt of the Earth causes the hemisphere to be away from the sun, then the angle is going to be less, which means the sunlight spread out and it is cooler. And here's a picture to show that. And you may want to draw this in your notes as well. So in the summertime, you've got the sun way overhead, and it's pretty much at a 90-degree angle. So when that sun is hitting at almost a 90-degree angle, if we were to go here and here, then the sunlight is going to be very concentrated in a very small area, which means it can be heated up. But in the winter time, the sun is at a very low angle. You see how much lower in the sky it is? And because of that, you've got about half the angle than during the summertime. So you've got it at about a 45-degree angle coming in. And because of that, then the sunlight is spread out more. See how much of a bigger area that is? And so that means that it's not able to heat the ground up as well, because now the sunlight is spread out. So the greatest changes in temperature occur at the north and south poles, because the sunlight angles change the most during the year. And at the equator, the sun is almost constantly overhead, so temperatures change very little. So let's take a look at what that looks like. Hello, Mr. Sun. All right, so looking at the globe on the left, the Earth on the left, okay, we have the northern hemisphere tilted towards the sun, which means the northern hemisphere has which season? Hopefully you said summer. Okay, and down at the southern hemisphere it has winter. Okay, now the sun is very concentrated, or is very directly pointed at the northern hemisphere. So that's why this part is getting warmer. However, the angle of the sun on the southern end is a lot less, and so it's not getting as much direct sun, so it is not getting heated as much, which means it's winter. Now the opposite is happening when the Earth makes that revolution around the Sun. But remember, it still has the same tilt. That hasn't changed. But now the northern hemisphere is pointed away from the Sun, and the angle of the Sun is less. So let's see, if you're up here, how it's not hitting it as directly anymore. But at the southern end, it's really hitting it. Now you're also going to notice that here at the equator, here's the equator right here, that in this area, it's pretty much hitting it. The Sun is hitting it at the same angle, whether the Earth is tilted this way or that way. So that's why at the equator, the temperature here is pretty consistent, probably 75 to 85 all year round. Wouldn't that be nice? Now, how does that affect the length of the days? So near the North and South poles, the changes in the length of daylight changes dramatically throughout the year due to the tilt of the Earth's axis. Near the equator, the amount of daylight and darkness is almost equal year-round due to the consistent angle of the sunlight. What does that mean? Well, let's take a look. Here comes Mr. Sun again. All right. Now, you see here along the equator that the sunlight is pretty much hitting it the same number of hours no matter what time of year. So because of that, the equator has pretty much an equal amount of sunlight and darkness. So they pretty much have 12 hours of daylight, 12 hours of nighttime. But at the poles, because of this tilt, there are times when the northern hemisphere never has the sun setting. You always have the sun. And if you look in your book on page 49, you're actually going to see a set of pictures that shows that the sun never sets. And this occurs, towards the North Pole and in Alaska, where it is daylight. It is always light for about 3 months of the year. And in the southern hemisphere, the South Pole, when the Earth is tilted away from the sun actually never rises. It never comes above the horizon. Okay, so you can see that here, because the sun, remember, only can hit half the Earth at a time. And so there are 3 months of the year where it never rises. It's always dark, which sounds neat at first, but I know that after a while it gets pretty old. All right. Well, let's review everything we've talked about in all 3 screencasts by visiting the Office of Naval Research. All right. So there are parts of this that we're going to go through. I realize that you can't see the whole screen, but you only need to see some of the main little parts here. All right, in the very first screencast, we talked about day and night. Okay, and how at any one time, only half the Earth is in the lit side, and the other half is in the dark side. And it takes 24 hours. Whoop, it's going to go around again. Stop. It's going to take 24 hours for the Earth to rotate on its axis. And when the part of the Earth that goes into the sun, it turns into daytime. And then when the Earth turns into the dark part, then it's nighttime. I'll do it one more time. And there we are. Okay. We also learned that the Earth has a revolution around the Sun, and it takes how long? 365 days, or a year, for the Earth to revolve around the Sun one time. And you will notice that as it is revolving around the Sun, that the axis of rotation is always pointed in the same direction. You'll also notice that the orbit of the Earth is in an ellipse. Remember, Kepler found out that planets' orbits are in ellipses, not in circles. Okay. Next, we talked about how the seasons, or the angle of the Sun, caused either it to be colder or warmer. So in the winter time, when the Sun is coming at a 45-degree angle, so if we put our line down here and made a triangle, this would be a 45-degree angle, and the light is spread out, and therefore it is cooler. However, in the summertime, when it's coming directly overhead at that 90-degree angle, then the Sun is very concentrated and it heats up the Earth much more. We also talked about the summer solstice and the autumnal or fall equinox. And remember that because of this tilt, it causes either different amounts of light to be hitting the Earth. So during the summer solstice, here we see that there is an equal amount of sunlight hitting there is a more light hitting the northern hemisphere than the southern hemisphere, and because of that, it is summertime in the northern hemisphere and winter in the southern hemisphere. If we travel to the autumnal equinox, remember equinox, equal amounts of sun in the northern and southern hemispheres. So in the northern hemisphere it is fall, and in the southern hemisphere it is spring. Then we have the winter solstice, and during the winter solstice we have more of the Earth tilted away from the Sun, which means we have a very little amount of sun, a minimum amount of sun hitting the northern hemisphere, and a maximum amount of sun hitting the southern hemisphere. So it is winter in the northern hemisphere and summer in the southern hemisphere. And then finally we have the vernal equinox. And during the vernal equinox equal, we have equal amounts of sunlight. It is spring in the northern hemisphere and summer in the southern hemisphere. Okay. Now we'll watch as the Earth goes around the Sun. Let's hide the Sun there so we can see. And notice how that axis does not change. It's constantly pointing in the same direction. Okay? All right. That brings us to the end of screencast number 3. Please make sure to go back to your notes and come up with questions for all of your points. Thanks.